Hey, hi. So, actually, we had to discuss some concepts, right? So, let me start and let me pull out that note where I noted everything. Not here. Yeah. So, first one is binary search. In this one, I was looking for return thing, right? So, I was looking for the return here. Why the return is important? Let's write down rough binary search code here, and we'll see. Okay, so let's write down in functional approach, right? I mean recursive approach. Void, not void actually, int. This will take int right side, left side, and target and array. Okay, so first we will be checking if only creating mid, right? So int mid equals left plus right by 2 if target equals ARR of mid, then return mid. This will be the answer. Now in what case we will not be returning, let me hide it. In what case we will not be returning mid is just a second. The case in which we will not be returning mid is if ARR of mid is greater than target, then we will be doing return here, right? Return bin of. So this is great. The answer is great. Then we will move to left side. So right will be fine. L minus, I mean mid minus 1 RR target. ARR. Now what was the code which I wrote? I want to write it exactly same. Anyhow, if ARR of mid is less than target, then left side is discarded, means return R plus 1. Okay, so what we are doing, right R plus 1, no, not R plus 1, means mid plus 1 comma left comma target comma ARR, and at the end just return -1. I guess this is it. Yep. Now this is line number 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do it. let's first check this condition. If ARR of mid, like whatever it is in the middle, I mean whatever index we have is greater, we got something here, x, which is greater than target, so we will be moving right side, I mean left side. Why this is confusing me right now? 1 2 3 4 5. Let's say this is a target is less than mid value, that is 3, and target suppose 1, then we will go to this side. To go to this side, left will be as it is, right will be mid -1. Yeah, now it's fine. Now let's start why return statement is important. Let's work with this example. Let's have an array, like ARR equals ARR equals -1, 10, 30, 50, 60, 100. Okay, so we have target equals 10, L equals 0, R equals 1 2 3 4 5 6, R equals 6. And let's start in a dry run. So in case of dry run, let me make it smaller, so I'll have more space. So now let's do this from this example. We will be having this okay, let's start. So where should I put it? I guess here only. So first iteration will be in white, so mid equals 0 1 2 3 4 5. Now I'm taking too much time maybe, but yeah, this is my channel, I don't give a fuck right now. So mid will be 0 plus 5 by 2, that will be 2.5, that will be 2. So at index 2, so we got 2 as answer, and target 2 is not equals to not 2, ARR of 2 is not equals to 10 and this value is 30. So this case will be applicable. At this case, a new stack will be opened. One stack, it is still there at this point. Now another stack is started. This is first stack, this is second. I mean the value of second stack. I mean I can, I'll make it prettier later. Wait, in some other question explanation. So in second stack, so yeah, we'll be calling this with the value L is untouched, that means 0, and comma mid minus 1, that is 2 minus 1 is 1, and comma target and array we have, right, already, same thing. So target is 10, comma ARR we have called. Now after getting called, we will find mid. Mid equals here this time 1 plus 0 by 2 equals 0.5, that is equals to 1. So 1 we got. Now now target equals ARR of 1, that is 10, target is 10, matched, returned answer is returned as 1, right? So this function will return 1 here, but suppose this return was not there, this thing will not be getting used in that case, and next statement will start executing, right? And then this next statement answer, I mean this is popped from the stack. Now again this function is running. So yeah, in this case we are here and we'll check if ARR of mid is less than, so this is a false condition, so this will get skipped, and at last -1 will be returned, so that is false. But if there's a return, suppose suppose the return is there, so if the return statement was not there, we are getting wrong answer. But now as we have the return, means this value will be like this function will stop here. This function will stop here at this place, and it will return the value 1 at end. Yeah, fine, got this working and understanding done why return was important. Now let's see other there is DFS flood fill. What was my doubt in this? Let me remember it myself. In flood fill, actually I was thinking about the DFS solution mainly, I believe. Yeah, and in the DFS solution no, I guess flood fill is fine, no need to think about it. LCA tree, was there anything to think about? Yeah, return statement thing was only there to think about. So let's check what's in the what is the solution which I have written. I'll first try to write the solution here. I'll see. I do remember the question. Let me check if I understood the solution and rewrite it faster this time here. So if, not if, LCA solution, right? Let's start writing the solution. LCA tree node root, tree node P, tree node Q, and yeah, I guess that's it. 3 parameters were there. And starting from here, now I need to write the solution. I did this in a recursive way, so I will write the recursive solution first. So we'll check if so it should be between, and I use the tree node property, I mean in balance LCA of binary search tree of BST. So using the binary search tree property, I have done this, and we can first check if the solution is there, right? If P well, I was like I have swapped this, right? So if P well is greater than Q well, swap P comma Q, right? Next I started if P val is smaller than Q val and not Q val, I mean root val and Q val greater than root val, return root, else we were moving to the place. We're checking if P you're checking for P is right? If P right is possible, then we were calling it out with no, root right. Why P right? It sounds like I have memorized it by heart. Root right is there, then we are calling it LC with return LCA return LCA root right comma P comma Q and else if root left return LCA root left P comma Q and return root. That's it. Yeah, so I guess this should be the solution. Let's cross check. let's check out the submission. I've done one. Yeah. And this was my code. Alright, my code is very different. Actually, maybe the question is not in front of my face. I messed it up. The answer. So decision of going right and left should be based on current value of root compared to p-val. Yeah, I guess we can stop the recording and I can accept I'm very big noob. Okay, yeah, I'll try my best though. Okay.